Hello, and welcome to this lesson on the relative masses of subatomic particles within our broader unit on atomic structure and the periodic table. In this lesson, we'll start by looking at the relative sizes of atoms and their nuclei by understanding the relative sizes of atoms and their nuclei, recognizing the concentration of an atom's mass within the nucleus. We'll then look at the relative mass of subatomic particles. You will understand the relative masses of protons, neutrons, and electrons within an atom, and recognize their significance in determining the overall mass of atoms. Let's get started! From our last lesson, you will be familiar with the relative charges of protons, neutrons, and electrons. Building on this foundation, today's lesson will enhance our understanding by diving deeper into the specifics of atomic structure. By exploring the relative sizes of atoms and their nuclei and understanding the distribution of mass within an atom, we can gain clearer insights into how atomic structure influences chemical behavior and properties. Atoms are incredibly small, with a typical radius of approximately 0.1 nanometers, which is 0.0000000001 meters. To put this into perspective, even if you were to place 10 million atoms side by side, they would still only span about a millimeter. However, the nucleus of an atom is even smaller than an atom itself. The nucleus's radius is less than a 10,000th of the size of the entire atom, approximately 10 to the minus 14 meters. This means that if an atom were the size of a football stadium, the nucleus would be about the size of a marble in the center of the field. The masses of atoms and subatomic particles are very small. Therefore, we do not write their mass in kilograms, but instead use their relative mass, which allows us to compare the subatomic particles to each other. Protons have a relative mass of 1, and neutrons also have a relative mass of 1. This tells us that they are the same weight. In contrast, electrons have a very small relative mass compared to protons and neutrons. Specifically, the mass of an electron is approximately 1/2000th of that of a proton or neutron. Because of this significant difference, the mass of electrons is typically negligible when calculating the overall mass of an atom. Therefore, despite their small size, almost all of the mass of an atom is concentrated within its nucleus. This is because the nucleus contains protons and neutrons, which have much greater mass than electrons. We can represent this information about the relative mass of subatomic particles in a table, which also has information about their relative charge, which we studied last lesson. Well done, that's the end of our lesson today. Let's recap. In today's lesson, we delved into the relative sizes of atoms and their nuclei, alongside the distribution of an atom's mass. We learned that atoms are extremely small, with a typical radius of about 0.1 nanometers, or 10 to the power of minus 10 meters. The nucleus of an atom, however, is even tinier, with a radius of approximately 10 to the power of minus 14 meters, less than 1/10,000th the size of the entire atom. We also discussed how almost all of an atom's mass is concentrated in its nucleus because it contains protons and neutrons. Protons and neutrons each have a relative mass of 1, whereas electrons, which orbit the nucleus, have a much smaller relative mass of about 1/2000th that of a proton or neutron. This means that the mass of electrons is negligible when determining the overall mass of an atom. See you in our next lesson.